Well, good morning, good afternoon, or good evening, depending on where you are in the world, and welcome to today's DevOps.com webinar, brought to you by TechStrong and MinIO. My name is Cody J. Brown. I'm the host of TechStrong Learning, and we have an exciting presentation for you today. First, I have a couple of housekeeping notes to cover. Today's session is being recorded, so if you miss any of our discussion or you'd like to rewatch or share with a friend, the on-demand version will be made available shortly after we conclude our live session today. If you have any questions, we want you to go ahead and send those in to us using the Q&A tab, which can be found on the right side of your screen. That's also where you're going to find the chat tab, and that's where we want you to get to know your fellow audience members. Let us know your thoughts throughout today's webinar, or just tell us where you're from. I will also point out in the handout section, we have a version of the slides that are available for download, so feel free to download those to follow along at your own pace. And before we close, we will be giving away 4 $25 Amazon gift cards, so be sure to stick around. Our topic today is using external tables to store and query data on MinIO with SQL Server 2022. And I'm joined by Hugo Quiroz, engineer at Microsoft, and Moise Kohari, technology leader at MinIO. Hugo, Moise, thank you both so much for joining me today. I'm going to let you take it from here.
Thank you very much, Cody, and thank you everyone for joining. As we mentioned, this webinar is going to cover external table capabilities and how to query data on MinIO with SQL Server 2022. As part of the agenda, we're going to speak to object storage and how it is being leveraged today. And then we will discuss the capabilities that SQL Server 2022 brings around leveraging external tables, object storage as external tables, and being able to do backup and restore to object storage, as well as data virtualization. Hugo is going to actually lead us through live demos of this. And towards the end, I will cover why MinIO for SQL Server 2022. To begin, my name is Moise Kohari. I have a technology background. I've been working in the industry for almost 30 years. I was previously founder and CEO of a data privacy company called Manitou. Prior to that, I was SVP and Global Chief Technology Architect for State Street Bank. And prior to that, I was with the London Stock Exchange as their Global Chief Technology Architect and Executive Vice President. Hugo, would you like to introduce yourself, please?
Sure. Good morning, everyone. My name is Hugo Queiroz. I'm a senior program manager here at Microsoft. I work for the Azure data team. I'm the PM responsible for the integration of SQL Server 2022 with object storage and also the data virtualization piece, which is Polybase for SQL Server 2022. I've been working for Microsoft for the past almost 9 years now, and I've been in the field as an engineer, as a DBA, as a tech leader, as a tech manager before. So it is a really real pleasure to be here talking about these topics with you all, and especially with Moise. We've been working together for quite a few months already, integrating SQL Server and MinIO. So I look forward to talk about these topics with you all. And before we can actually talk about those things, I just want to point out that everything I'm going to talk today about SQL Server 2022, it is related to CTP 2.0. That means it is a public preview product. We're still developing, we're still adding capabilities, so things can still slightly change. So I actually advise you all, once this presentation is over, to download SQL, download MinIO, test it out, try it out, and keep the feedbacks coming, because we still have we're still looking for the feedback to improve the product, right? So before we can actually talk about the advantages of object storage, let's take a few steps back and try to understand the major differences between the object storage and the traditional file system that we all probably know already. So the number one major difference between object storage and our traditional file system is the fact that in object storage, every single metadata related to the file, it is stored within the file itself. It is not stored in the file system metatables hierarchy kind of thing. It is stored within the object itself. So every single column, every single attribute, every single tag, it is stored within the object. And what that allows object storage to do is to be more flexible when it comes about attributes. You can have a certain file, certain object with different attributes. You don't have to respect and always inherited all the attributes from the traditional file system. You can have customization on the object level. And since every single metadata it is stored on the single object, then it allows also object storage to be more flat out distributed. So while in reality, the file system uses more a hierarchy type of thing, more like a B-tree type of thing, the object storage, it is more flat out. It is more like a heap. And by being more like a heap, it is usually cheaper and it is usually easier to maintain object storage. It is cheaper to scale out and it's easier to maintain. Because when you are adding a disk, when you're removing a disk, when you're doing some kind of admin task, admin workload, you're only affecting the end session, only those disks. You're not affecting the whole infrastructure of the traditional file system. So because of these things, object storage kind of became the go-to solution for everything NoSQL and everything big data. Every single big workloads that require a lot of amount of data, object storage became kind of the go-to solution for all of those things. So we wanted SQL Server to leverage that power as well. And object storage, it is not necessarily a new technology. It's been around for more than 15 years already. It is a tried and true technology. And we have different offerings, we have different products, we have different solutions based on object storage. So from a compatibility standpoint, everything that is compatible with S3 compliant APIs will be 100% compatible with SQL Server 2022, especially, for example, MinIO. MinIO follows to the letter S3 compliant APIs, therefore it is compatible with SQL Server 2022. Object storage has, as I mentioned, many flavors. It can be on-prem, it can be on the cloud, it can be a hybrid scenario. Then I'm sure Moise can speak about those things from a MinIO perspective on the next slide.
So the manifestation of object storage as primary storage, you will see that across the board. Snowflake, MariaDB, Microsoft SQL Server are all leveraging object storage. There are many AI ML workloads that actually leverage object storage. Frameworks like Kubeflow ships with object storage and MinIO object storage out of the box and leverages it for storing all types of logs and internal data on MinIO to begin with. Spark, Splunk, there are extensions to all of these with object storage. And object storage is leveraged for OS images, snapshots, backup restores, and Hugo is actually going to lead us through a demo of these capabilities. So what you will find is that object storage is not only being leveraged as application data store, but it is out of the box being leveraged as primary storage instead of some of the older generation storage technologies that some of us might have grown up with.
Right. So now that we know some of the benefits of object storage, it is pretty clear that we need to find a way to leverage that power into SQL Server, right? So we are doing two major capabilities. We are adding two major features in SQL Server 2022. Related to object storage. The number one feature is the ability to backup and restore to object storage. We've just learned it is usually cheaper and it is usually easier to maintain object storage. So it only makes sense for us to be able to leverage that backing up and restoring data into object storage. And we also want to enable what we're calling data virtualization, which is our solution for Polybase. So data virtualization is a concept that has kind of many meanings. Here at Microsoft, on my team, we define that data virtualization, it is allowing SQL Server to be able to access any data anywhere. So SQL Server should be able to access your data on-prem, your data on the cloud, your data using the traditional file system, data in object storage. It doesn't matter where data is. It can even be on another database. We want SQL Server to be your hub. We want to leverage that power through object storage to be able to connect to every single endpoint, every single data you have in your company, and use your very own SQL Server that you know and love, that you've been using for decades now, to leverage that power, right? We want to bring that power into what you already know, that you already use. And the key takeaway here is that we are doing those things without requiring a new SKU, without requiring a new subscription, without requiring new services. Everything is baked in the product. Everything it is there for you to use natively, and everything you can use using the same kind of command that you know and love, and the same kind of architecture, like accessing a table, for example. It is the same thing. So let's take a quicker dive into how are we integrating SQL Server with object storage, at least from the backup and restore perspective, right? So on our left side, we have our SQL Server. It can either be on the cloud or it can be on-prem. Right now, this feature is for box product only. So when I mention in the cloud, I mean as a virtual machine. And on our right side, we have our MinIO object storage provider. And for SQL Server to leverage that, to establish the connectivity between SQL Server and MinIO, we require an HTTPS connectivity. We require an HTTPS endpoint for security reasons, right? So to ensure this HTTPS connectivity, we require that you install a certificate. It can either be a public certificate or it can be a generated open SSL certificate on both the MinIO server and on SQL. Once you do that, once you install the certificate, we can create a credential on SQL Server. I'm going to do a demo to demonstrate all of those things. But we create a credential, which is basically a way for SQL Server to know the MinIO password and the MinIO login. And then we're going to do a simple backup to URL command. As you can see in the slide, in the URL, it starts with S3. So whenever I run a backup to URL and the command starts with S3, then SQL Server will know I'm pointing to an object storage. And by pointing to the object storage, it will check the credential, it will check the CA, and will establish this HTTPS connectivity with object storage. So from a command perspective, it is just like a backup to URL. Nothing changes. You don't need to learn anything new from a T-SQL perspective. That said, as I mentioned before, object storage is a new architecture, right? It is a new way to store data. It is different from the traditional file system. And one of the key things it differs from a storage perspective is the fact that the object, it is stored within what is called parts. Parts is like a blob when you're talking about a disk, a traditional, for example, Azure Blob Storage. It uses blob to store files. Here on object storage, it uses parts. And every single object can take up to 10,000 parts, no more than that. That's a definition, that's a requirement of the architecture itself. It's nothing to do with SQL or MinIO. Every single object storage can take up to 10,000 parts per single object. But as I mentioned before, the object within the S3 can be quite flexible. And one of the things they can be flexible about is the part size. So every single part can be from 5 MB to 20 MB. Right, so a single object can take up to 10,000 parts, and each part can vary from 5 MB to 20 MB. So that allow us to make a single URL capable of storing anywhere between 75 gigs to almost 200 gigs. So 75 gigs if you're using our default configuration, which is 10 MB, or around 195 gigabytes if you're using part size of 20. And that part size is controlled on a SQL level by using the parameter max transfer size. So by default, SQL Server will automatically assign each part the size of 10 MB, but you can change that anywhere from 5 MB to 20 MB on a SQL level. Doing our internal testings in our labs, we found that 10 MB seems to be the best value for the overall configuration. But there are cases where going below 5 MB or above 10 MB, it can be beneficial, especially if you have some kind of network constraints. So we advise you to try it out, the configuration. So if you need, for example, if your database has more than, for example, 200 gigs of size, we can stripe that into several different URLs. So we can take up to 64 URLs on SQL. So for each URL, we have 10,000 parts, and for each 10,000 parts, we have the part size of 5 to 20 MB. and we can split that across 64 URLs. That gives us the overall capability of backing up a database of roughly around 4 terabytes from SQL Server to an object storage. And 4 terabytes without compression. If we add compression, which we strongly advise to add compression, it has several benefits in this scenario. Not only compression is required to control the max transfer size, but we've seen the benefits of decreasing the size of the database anywhere between 3 to 5 times. So you can have up to 4 terabytes of database backing up. It's without compression. With compression, it can be around 10 to 12 terabytes of data storage on a single command of a single database, right? Of course, the object storage, MinIO, is capable of much more than that, but for a single database, that's our current limit. And that limit, again, it's CTP 2.0, right? So things can still slightly change. We can still fine-tune those things. So what I wanted to do now, since it's probably a lot of information taking, a lot of technology to take in, I want to go into a quick demo that hopefully will explain these concepts a little better. So let me share my screen 1 second. Can everybody see my screen? I hope so.
Yes.
So I'm gonna do a quick demo here. So first things first, let me do some housekeeping. So as you guys can see now, I'm running on CTP 2.0, SQL Server 2022. The first thing, as I mentioned, was to create a credential. So I'm creating credential. I have to pass over as a parameter the S3 in column, then the IP address, and then the endpoint. This backup here, it is the bucket. And the bucket, it is more like a file infrastructure. So if I go into my MinIO server, that's my MinIO interface. Hold on a second. I have a folder called backup. So that's where I'm going to store my SQL backup. So I'm pointing that in my SQL command. I'm sending over access key ID and the secret key, which is pretty much the login, the password for the MinIO server. So if I go into, for example, let me go back into MinIO. We can go into access. I have a user called Contoso admin. So I'm using that user to connect to object storage to MinIO. So I'm using that Contoso admin, Contoso PWD as my credential. I'm going to create that. 1 second. Let me lower this, make it easier to see. Then I'm going to back up the database, just sending over the IP address of the server. We support both IP addresses and virtual host, and we can also support region as well. But for this example, I'm using straight up IP addresses and the endpoint. Again, this is the bucket from the MinIO, which is the file structure. And this is the file I'm backing up to. I'm using compress, and I'm using format here, which is just a way to overwrite whatever I have in that bucket. So the backup just went through. If I go into MinIO, go into browse backups, you can see the backup is already here, right? But as I mentioned before, let's say, for example, your database has way more files, it's way bigger than this. It's have several terabytes of data. Then I'll just start adding a lot of URLs here, right? As you can see, I'll be, for each one of those URLs, it is max transfer size times 10,000 parts. So my max transfer size here, it's defined by bytes. So this number, it actually means 20 MB. So 20 MB times 10,000 parts, so roughly 195 gigabytes for each single URL. So I'm splitting that across 5 URLs. Before I can actually run this command, let me try to do something here, I think, to showcase the fact that I've mentioned before that we are 100% compatible with everything S3 API. So let me go into trace. Let me enable a trace here, and we're going to see when I run the backup command, we're going to see the traces on the MinIO of the backup command happening. So we can see the put objects request, the complete multipath authentication, the complete multipath, and then we can see on the left side the backup completion. If I go into MinIO, Go into bucket, browse. We can see the files here, right? And the same kind of idea, nothing changes if I want to restore, for example. Hold on, let me just double check SQL to see if the backup's there. You can see I took 2 backups. One was a single file and the other was stripped across several different URLs, but you can see 2 backups here. And the same kind of approach happens with a restore database. It's the same thing. I'm using backup to URL. I'm using pointing to S3. I'm using the IP address, the endpoint, the backup, and the file. I'm going to move the files, and I'm going to rename this database SQL Server AdventureWorks 2021 just for not being safe, not replace the one that I already have. So if I run this from MinIO, if I go here and refresh, you can see the database AdventureWorks 2021 that I've just restored. So looking at the T-SQL, there's nothing new here, right? All of those things that I did, it is just plain old SQL Server backup and restore commands. The only difference is that I'm using a URL and I'm pointing to an S3. That's only overall.
So this is very exciting. What you're really showing is that a user can back up any number or as many times as they want their database to any cloud using MinIO, where it could be in any cloud environment, and they can back up on-prem if they want, leveraging S3, and be able to restore from them as necessary and needed. And that could potentially be automated if they wanted to do it occasionally.
Exactly, Maurice. And it doesn't need to be also only on the cloud. You can have your MinIO on-prem, you can have your MinIO on the cloud, you can have your S3, whatever it is, as long as it is an object storage compatible with S3 REST APIs, and you have the certificate installed, SQL Server will be able to handle those things.
Nice.
Right. So let me go back to the presentation real quick. So that's one capability we introduced with SQL Server, right? I mentioned 2 with object storage. The number 1 was the backup and restore capabilities, and the number 2, it is the data virtualization, right? And data virtualization, as I mentioned before, is enabling SQL Server 2022 to connect and access any data anywhere, not only SQL Server data, any type of data we want. That's our goal. That's our vision right here. So we use that through Polybase. So imagine a scenario where you have your MinIO, your object storage layer, receiving data from IoT, receiving data from Event Hub, receiving data from spreadsheets from other departments, or even other database files, another database, all of those things. And you want your SQL Server to be able to work with that data without necessarily ingesting that data. We don't want to load duplicate size of data. We just want SQL Server to be able to access that data without ingesting that, right? Of course, we have the capability of ingestion if we want to, but we just want to be able to access where the data is. That's the key point here. And we can do those things with Polybase pretty much almost the same way as we did with backup and restore. The only major difference is that backup and restore, it is a feature instance-wise, involves the whole instance, while the Polybase, it is a database-wide feature. And what that allows us to do is a bit more control over who's going to use Polybase. And for that control, we need 2 more extra steps compared to backup and restore. And the 2 more steps we have, it is the ability to create a master key for security reasons in the DB scope credential. So since we are controlling on a database level, we have that 2 more requirements. But aside from that, it's pretty much the same architecture as we saw on object storage. So I think probably better if I showcase a demo about this. So let me share my screen once again.
So Hugo, what you're saying is that if data is being ingested directly into S3 in Parquet format or CSV format or some other format that you would support, that data is now available to SQL Server to do all types of analytics without even ingesting it in.
Exactly. There are scenarios that are really important scenarios where we advise to ingest the data, but most of the times when you're gonna run a report, when you're gonna do some kind of analysis, you can leverage that without interfering with your SQL Server, without getting the data, the load into your transaction database, right? Your SQL Server, it is running your transaction database as it's always been, and you can use that to do more than just that. You can use that to do some kind of analytic workload. So, for example, again, I'm using SQL Server 2022, CTP 2.0 here. I'm going to enable the feature Polybase. That's the only requirement we have here. So I'm going to do is sp configure Polybase enable value. Let me run this. And for this particular demo, I'm using a data set from Movie Lanes. Movie Lanes has a public data set with ratings from movies. It has more than 25 million movies there with ratings. So I'm using that as a Parquet file to showcase the demo. And if you go into the S3, I actually have a bucket called movies. And inside this bucket, I have two files, the CSV files and the Parquet files. For this demo, I'm going to use Parquet, which is the go-to file format right now because of the columnar compression. And I have several different Parquet files over here. So I'm going to access those files, which is stored in our MinIO through SQL without necessarily loading anything on SQL. So what I do is, first things first, I'm going to create a database. This database I'm going to call data virtualization. And as I mentioned, we have two extra steps, right? We have the creation of the master key because we have to encrypt all the credentials on a database level. So I'm creating master key here. As you can see below, database master key was created. And I'm going to create a database scope credential. And database scope credential is pretty much the same thing as we have on the backup and restore. I'm just saying, go to S3, use this login and this password. And then finally, I'm going to create the external data source, which is pretty much the pointer to the S3. So the URL, the IP, the endpoint, and the bucket. So, and I'm using as a credential, the scope credential that I've just created. So this way we can allow several different types of users, several different personas to access those files without worrying about what is the password, what is the ID. I don't need to share that thing. I can just create the database scope credential and they can use that on their own. I don't need to send it over the password and the login. So right now I'm gonna do a typical select star, point it over to the bucket, to the Parquet file and the movie Parquet file, right? So I'm gonna do this and we can see all the results from that Parquet file is already here. So I'm accessing a list of 62,000 movie lists in 1 second, right? And with my machine, it is just a four-core virtual machine right now. And I can get those numbers on SQL and MinIO. So 62,000 rows of movies in 1 second. So that's accessing straight up a select star from the file. I'm not ingesting anything on a SQL level. But let's say I have a way bigger role. Let's say I have a big table and I need to do some kind of convert. I need to do some kind of data manipulation. So I actually do have a Parquet file with 25 million rows. This Parquet file, it is called ratings. And since I'm going to do a lot of data manipulation, for this case, for this example, I'm going to create locally a table called ratings. And I'm going to load that table with this Parquet file. Right, so I'm doing pretty much the same command that I did before. A select, I'm gonna use the column ID, movie ID as a column. I'm gonna use the ratings ID. I'm gonna do a convert. I'm gonna change the type format, which is usually a very expensive SQL command to do. And I'm gonna load everything into this ratings table. Again, 25 million rows to be ingested in a SQL Server from a Parquet file using MinIO. And it took 15 seconds to do so. This is the amount of rows we just ingested into SQL. And since we have that into a local table now, all the things we know on SQL Server, it still works, right? I can create a cluster index. I can do splits. I can do this. Every single command we have on SQL, we can still do that since we have the table locally. But let's say, as I mentioned before, I don't want to load that table in. I want to just create an external table, which is pretty much a pointer to the Parquet file, and I want to leverage that, right? So to create an external table, the first thing we need to do is to create an external file format. I'm going to create this external file format, call it that Parquet file format, and I'm going to say whatever data I'm using, it is actually a Parquet data. So first thing that I need to do is this. And then I'm going to create external table, send you over the Parquet file location. And now I've created this external table called external XGT movie. And if I select this, again, I'm selecting, it feels like I'm selecting an internal table from SQL, but it's actually an external table that is pointing to the Parquet file I've just loaded. So I can even create statistics on that external table. So right now we have three different scenarios, right? We have the open rule set select star, where we just got the data from the Parquet files. We have the ability to load whatever data we want into SQL by creating a table. I loaded that from select star, select into, and now we have the external table as well. So we have three scenarios here, and we can use all of them together. So for example, now I'm going to create a view using those things. I'm going to create a view using the external table that I've just created and doing the local table that I've just loaded. I can do two strategies at once. And now I can just run my typical SQL command where I want to say, for example, movie, the genres, the ratings, all of those things. I'm doing inner join, I'm doing replaces, I'm doing converts, I'm doing a lot of technically T-SQL heavy commands. And you can see it took like 14 seconds to run. And now I have, for example, the list of movies, the ratings, the release date, all of those things. And part of that, I'm loading data into SQL since this table is local, but part of that, I'm accessing the Parquet file where it is. I could definitely leave the file where it is and just do external table all the way, but I just wanted to showcase the fact that we are adding the capability, but we are integrating that capability with everything we already have on SQL. So you can use both ways, right? And we can go on with those demos if you guys want to. We can, for example, know what are the top 10 movies according by ratings from this database. I'm accessing this view here. I'm doing sorts. I'm doing top 10s. And you can see it's quite responsive, right? Half of the data, it is local. Half of the data, it is external. And we'll be able to access those things as if you're accessing like a normal T-SQL command without learning any new language, without running a different server, without running a different SKU, and a different subscription, different platform. We are using plain old SQL Server for those things, right? So
That is amazing. I have to tell you, I ran technology for a couple of some of the largest financial institutions out there, and I would imagine this has to be a similar problem for other industries. The ability to be able to access data where it is instead of needing to copy it over and over again. So now you're not carrying hundreds of replications of that same data, and then someday you need to reconcile it. It is an amazing capability that you guys have brought to the market.
Yeah, and for this demo, Moise, I only focus on the Parquet aspect of it, but the same thing applies to another SQL Server, to Oracle, to Teradata, to whatever data is. Chances are we might have the connector to do those things. The command is pretty much the same. The only thing that's gonna change is your external data source. The only thing that's gonna change is this. Instead of saying S3, we're gonna put the IP address and the string for the other database of the other type of file. That's the only thing that's gonna change. Everything else is just like as we saw here.
Nice. Yeah, I mean, again, like I said, not needing to replicate data over and over again is awesome, and the speeds that object storage is providing is amazing from a performance point of view. So if we can maybe get back into the slide mode, I would like to cover a couple of things as to why MinIO for SQL Server 2022. So MinIO, as you may know, is a minimalistic object storage. It was created in the cloud for the cloud. It's Kubernetes native. It was written from scratch. And it's the only object storage that provides multi-cloud capabilities where you can be in any cloud, any public cloud, as well as on-prem, and be able to leverage the same S3 interface, which is really the interface from an object storage perspective today to begin with, without really ever needing to rewrite your application. So you could be in any cloud and not need to rewrite your application, and your application is going to run and provide some of the best performance that you're going to find anywhere for storage capabilities. So some of the guiding principles for MinIO really, as I mentioned, it is born in the cloud. That's the cloud native DNA. It is highly performant, and I will cover some of the performance benchmarks that you will see where we are really providing line speeds for the types of environments that you can deploy on, whether it be HDD-based or SSD-based. And this is all commodity hardware, which is something that you won't find if you're leveraging proprietary solutions from a storage perspective. And MinIO was really designed with one core principle at its heart. The founders were pedantic about this. It is simplicity is at the heart of it. So anything that guides us away from that simple approach, it simply will not happen. So what that has really delivered is a very small static binary that you can run anywhere. And be able to get the performance that you're looking for and full S3 compatibility from an object storage perspective. So the benchmarks that I was referencing, the most interesting that I find is the fact that for NVMe, MinIO is able to deliver 350 odd gigabytes per second get performance and 165 gigabytes per second put performance. This performance metric and information is available on the MinIO site. There is no black magic here. You can set these environments up yourself, be able to reproduce it. It is very simple to set up, and MinIO team has many different architectural guides and blogs on the site. You can follow those, be able to set up pretty much any type of a test that you would like, and the team is available to help as well. So what makes MinIO so fast? MinIO is built as a single layer object-only storage platform. So there is no complexity in it. Latency throughout the platform is very, very fast. So in order to deliver that latency, MinIO leverages acceleration, where parts of MinIO is written in assembly language. So AVX 512 and so forth gives you hyper fast performance on commodity hardware that you're running on. There is no metadata database. So metadata is actually part, and Hugo mentioned this as well, is part of the object storage itself. And it combines Go with Go assembly in such a way that the performance is better than what you may find writing a similar type of platform in C. So again, like I said, from an object storage perspective, the performance that you will find with MinIO is uncomparable. It's fully S3 compatible, which is really at the heart of it. So 100% API compatibility with Amazon S3. And it gives you that capability, again, in a multi-cloud environment. So you could be deployed in Azure, on Google Cloud, and still be able to leverage the same API, as well as on-prem. It is Kubernetes native. So when you design these Kubernetes pods and you deploy them, you're able to move them around between these cloud environments, and you don't have to worry about really trying to migrate and port these applications from one environment to another. Immutability is at the heart of it. Cohasset has done a report on it. So it fully complies with SEC, FINRA, CFTC requirements around immutability and audit capabilities. And again, much of this data is available on the MinIO site. It integrates with all types of access management platforms such as Ping, Okta, and others. So you can really leverage whatever your organization may be using, WSO2, and you'll have full compatibility. Encryption and tamper-proofing is part of it. So everything in flight, everything at rest is fully encrypted. You have SDKs that give you the ability to programmatically be able to leverage the platform. And Lambda Compute is a fantastic capability that Amazon had introduced, which allows you to actually trigger certain types of events based on the event. A alert can be triggered that can then trigger additional compute jobs that you may have for the types of things you may be doing. MinIO is at the heart of it, right? Does not require, and actually we do not recommend leveraging any type of a RAID solution underneath the platform, because the platform itself leverages erasure coding in such a way such that you can actually create a deployment that can scale and be highly resistant to failure, at a disk level, at a server level, at a rack level, and at a data center level, such that entire data centers can go down. And as long as you've configured this with our help, that you will not have any loss of data, if you will, and actually access to that data will continue to be provided to all of your applications and clients on as needed basis. And monitoring capabilities are present. There are webhooks available, Prometheus and other platforms that are fully supported right out of the box. So enterprises, as I'd mentioned, and Hugo also touched on this, are demanding multi-cloud. And there are many reasons for that, right? You have data everywhere, and this is part of what Hugo was speaking of with SQL Server 2022. You don't really want to or need to really bring that data in one place to be able to run the analytics jobs that you want to run. Portability is another reason why enterprises are demanding multi-cloud capabilities. Cost is a core reason as well, because sometimes it is much more cost efficient to be leveraging a particular cloud provider or on-prem capabilities, and sometimes it may be different. So your ability to be able to leverage any and all is a key thing. And continuity, being able to go across multiple cloud providers is, as rare as it may be for some of these cloud providers to be down, it does happen. So your ability to be able to leverage a multi-cloud environment, including on-prem, gives you your applications availability, high availability that you may not be able to get otherwise. And regulatory environments sometimes demand this as well. So, again, MinIO's multi-cloud credentials, it is on every single cloud, public cloud environment possible, on every private cloud environment, that supports K8s or bare metal provisioning capabilities. You can run MinIO. It can run on the edge. It has all the features, 100% compatible with S3, as I had mentioned earlier. It is the primary alternative to AWS. And it is being leveraged. There are close to 1 million downloads, Docker pulls on a daily basis with MinIO. And on the edge, because, as I mentioned, it is less than 100 megabytes, the binary, you can pretty much run it anywhere you want on any type of an IoT device that you would like, and be able to really bring in that data and then be able to run the different types of analytics that your organization may be looking to run. MinIO is directly available to almost all major marketplaces out there, whether it be Azure or others. So your organization, if you have an existing relationship with one of these marketplaces, you can literally download it and be able to run it right out of the gate. So in summary, what we really covered is that object storage is being leveraged as primary storage in the cloud. And that operating model has many benefits to an organization. And it is first-class storage. So MinIO ends up giving you that object storage capability in a way where there is no lock-in to any one cloud provider or any specialized hardware capabilities. It is actually being deployed on commodity hardware. As I mentioned, if you come to the MinIO site, you can see some reference architectures, but those are just reference architectures. As long as it's commodity hardware, it will run. The utilization, you can do a lot of things. And Hugo only touched on a few of the capabilities that you can really look at with Polybase. I'm really excited about some of the AI ML capabilities that Microsoft has been bringing to the market. And you can actually leverage with Polybase, and you can leverage MinIO and be able to create entire AI ML pipelines in literally a heartbeat. So it's quite amazing. And early access is available today. So if you come to the Microsoft site, and Hugo will provide those pointers, you can actually do an early access. You can run SQL Server 2022 with object storage, be able to run on-prem MinIO instances or in the cloud, and be able to experiment with all of what we've been speaking of. And as you need any assistance, we can be made available to you to help you with anything. With that being said, I'm going to leave a little bit of time for question and answers. So if you have any questions, please feel free. And Hugo, thank you for joining me again.
Thank you. My pleasure, Maurice.
Well, Hugo and Moise, we've gotten a few questions in, so let's just start taking them from the top.
Sure.
So I think this one is directed towards Hugo. Isn't the data being replicated in the table, and don't you just need to synchronize it back?
Great question. So the major use for external table in open rule set is for read-only purposes, right? We are not ingesting data back into the Parquet files with that command itself. And the main reason for that is that once we start to synchronizing data back and forth, since it is just a pointer, since I'm not loading the data into SQL, it can easily fall in a scenario where the attributes are not respected. So we can have like data integrity issues. So that's why right now, create external tables and open rule set are for read-only purpose only. That said, we have other tools and other commands on SQL that can allow you to export the data into that file, just not in the create external table format, let's put it this way. So it is something you need to be aware of and be cautious about, because since you are working with external data, other connectors might be accessing that as well. So
great, thank you so much, Hugo. So Moise, I think this one is for you. How would you suggest benchmarking performance?
So usually speaking, right, you can run, and in the block storage world, you had all types of benchmarks that you might have run. The easiest way to do that is you can really come up with whether you're trying to back up and restore from these databases, and you can benchmark that, or you can be looking at get put performance, where you have a data set that you want to be able to leverage. So whether you're writing that data by doing puts, or you're reading that data, you can come up with the data set and simply create a MinIO cluster. And that cluster, depending on what type of performance you're looking for, obviously, if you're going to run STDs, NVMe is going to give you the highest throughput and latency required, but at a slightly greater cost. So you can also do similar types of tests on HDDs and be able to see, slightly degraded performance, but at a much better cost. So, and our team is certainly available to guide, and we do have some references in our blogs.
Thank you, Moise. Hugo, is there a reference architecture for HW?
Not really, because from that perspective, nothing really changes, right? We are adding the new capability to something that's it is pretty much the same backup and restore solutions that we already have. So we don't have an architecture specific for that because the other architectures fall in that category really well. So you can use whatever we have already for those things. Oh, one thing that I probably forgot to mention, everything you saw here today, it works fine on Linux containers as well. So it is Windows and Linux feature. So that can kind of slightly change the approach for HI.
So, Hugo, can I be able to perform lock on one record or a collection using MinIO? And if so, some light on this would be appreciable.
Technically, object storage won't lock on a row level, right? So any object storage, not necessarily MinIO, it uses REST APIs, and the REST APIs will kind of create a buffer to load. And since we are only reading the data, chances are this lock might never happen.
So what is the availability window for the software solution?
Can someone give you more detail about this? Well, SQL Server.
I think the early access is available today.
Oh, yes. Yeah, well, SQL Server 2022, it is available today on CTP 2.1. So you can go into the link. I've actually posted the link, microsoft.com/SQL Server 2022, and you can download that and try. We are on CTP 2.0, sorry. In a few weeks, we're going to release CTP 2.1, so we're going to improve some of those features as well. I didn't show everything. So 2.1 still have more features, more compatibilities, more file formats coming. And you can try that out. And for availability of SQL Server, look for, it is still going to happen this year. I don't have the specific dates, but look to the end of the year, it's going to be released.
And Cody, there are tens of thousands of MinIO deployments running every type of application you can imagine. So MinIO's availability is, as of right now, it is available, and hundreds of organizations are leveraging it for mission-critical applications.
Awesome. Thank you. Thank you both. Moise, would MinIO replace the traditional storage system so on-prem servers can also use MinIO as the storage?
Well, actually, some of the largest clients that I am working with today are using MinIO as primary storage. They are bringing in data from every type of environment you can imagine, whether it's IoT data or log data or network data. And they're directly going to object storage, and then they're setting up different types of AI/ML pipelines to be able to do different types of anomaly detection, different types of predictive analytics workloads. So the easy answer is absolutely, that is happening right now, and some of the largest organizations are doing it.
All right, so I'm looking around just to see if we have any more questions. But while we wait for any last-minute questions, I'm going to go ahead and give away a couple of gift cards. So these are for 4 $25 Amazon gift cards. Our first winner is...
Hugo and I are not...
Before I can do that, Cody, can I issue a challenge for me and Moise for the next webinar we ever do?
Absolutely.
If you guys download SQL Server 2022 and MinIO and do your own lab, do your own thing, and tag us on LinkedIn or whatever social media you have, I'm sure to bring that up in our next webinar whenever we have one. And I'm going to say, oh, someone has that cool solution, someone has that cool demo, and we're going to give kudos to that person.
Oh, and they'll get an automatic gift. Excellent. That's a great idea. You go.
Great. Our first winner is Valentino T. Our second winner is Jessica H. Our third winner is Ember L. Our fourth and final winner is Chun-Li Y. So to the four of you, congratulations. Please keep an eye on your inbox to claim that gift card. But if you don't happen to see that email, please check your spam folder. Now, I'll also take this opportunity to remind everyone that this session was recorded. So following this panel, you should be receiving an email with a link to access the recording on demand. But you can also find it living on the DevOps website at devops.com/webinars, and be sure to look in the on-demand section. It will be waiting for you. So Hugo and Moise, I'm not seeing any more questions at this point. So is there anything that you'd like to leave our audience with before we close out? Any final parting words?
No,
I can't think of anything really. Thank you. Yeah, thanks for the opportunity.
We are available for any questions that anybody may have.
Great. Well, Hugo and Moise, thank you both so much for joining us today. I'd like to thank MinIO for sponsoring today's webinar. And of course, to our audience, we really appreciate you spending time with us today. We ask for one extra moment of your time to fill out a brief post-webinar survey that'll pop up on your screen here in just a moment. But otherwise, we do hope to see you at an upcoming TechStrong Learning program. Everyone, have a great rest of your day. Thanks again, guys.
Thank you, guys.
Take care, guys.